Okay, so I was doing a search for the OLF Simple Sans OC font and happened across the Go Engineer article, and basically says the stick font is available from 2014 on. So I went in to do a search and I didn't see it, but part of the problem with that particular font is it is more, I'm going to say, the dingbat-ish than something that is readable. So let's go back in, double check, go back to the font and type in OLF. And there it is. Hard to kind of tell. Simple CJK. So it'd probably just say, I'm not sure what the difference is, but we'll go ahead and hit OK. That spreads it out a little bit. Maybe because it's not going around, we'll go to 110%, and font size can go to 5. All right, so point is that that font is available. Type in the OLF. It's kind of hard to see. And when I did a search of my fonts, it's showing up further on down the line. So if I just looked for it, I probably would have seen it or done a better scan of it. All right, so what this is doing is if we zoom up, you're not going to see the double like we did with the simplex. And I've had pretty good luck with the simplex previously. One line font for a split feature. Now it's warning me that it can no longer do the cut extrude. It is one line. The split line comment is that it's going to try to cut it, so I would delete the cut extrude, make sure that your absorbed features is not turned on. We don't want to lose the sketch, and it goes back to this. So on the text side, when we go into the drawing, we're going to have to make sure that this sketch or the sketches are being shown. All right, so fonts have some applications. If we were to generate the curve or a circle, we can have the text follow that geometry and create the shape. So let's see, have the assembly. We'll come back to it. The crank is pretty much same geometry except for 50, 80, and 160 long. As soon as you see that, I hope you're thinking configuration. You can draw these individually. You can do the save as, copy and open, or you can create them as a configuration. So I will do the save as, copy and open, and then we will revisit the configuration. But I think I've beat that up enough, so I'm going to stay on the simpler side. We have part numbers and we have materials, and we will have to have that discussion about the materials when we get closer to applying all that metadata. All right, so our part metric. We can go to the front plane, open up a sketch. We'll go into the line, pull down, and grab the center line. And I'll go ahead and make a horizontal infinite length. And since we're here, we can go ahead and make a vertical. We'll probably use a little bit of both of those. All right, so if I draw my circle, and we could do the arc, but I'm fine with contours and regions. So if I generate those two circles and select, control select, and we find our mirror entities, that's going to generate the two shapes. One of the things that you want to watch out for picking the circle, we go into the line command and I want to pick the circle, but it's going to go tangency, and that's really not what I want. So I'm going to give that a Control Z, and if that happens, just draw your circle kind of out. usually does not have a problem terminating at the circumference of a circle. It's when you start. So if we go coincident and select control, select coincident, then I can mirror those across the horizontal, and they will kind of stretch and shrink because we haven't put any dimensions on these yet. All right, so we have the 9 millimeters for the through, and 10 millimeters or 9 radius of 9 on the outside, so 18 on the diameter and 10 millimeters through. And since we don't really have a dimension, again, we're kind of scaling the drawing, which is not preferred, but we'll make the center a 10 millimeters as well. All right, and in previous where we've seen this type of geometry, always make the point that from a manufacturing standpoint, we're not necessarily gaining a whole lot by doing the dog bone configuration. If there's a clearance issue, maybe, but realistically, I would, from my manufacturing standpoint, if I really needed to lighten this, I would rather have an knob round with a slot through the middle and the holes at each end. All right, but again, personal preference, easier to machine than trying to make the cuts. All right, so that gives me my geometry. We're going to go ahead and extrude this to 5 millimeters. And when I go through to make the selections, we're going to pick the regions and go to 5 millimeters. Advantage to bringing the part forward or going away. We go to machine this, maybe a little bit. I have that tendency to have it go away from the plane, but not really anything major. And then the radiuses of 5, so we put the fillet in. We can go into the box pop-up, and if I wait for that context, I will be able to pick the other two on the selection. Worst case, I rotate it over, I pick the other two edges, I go ahead and accept it. Now looking at that from the front, yeah, it looks pretty close. So we have the crank, the follower, and the coupler. So I'm going to save this as the crank. And I want to do, we save first, and then I want to do a save as. Make sure that I have the save as copy and open, because continue is going to stay in this file. I want the new file, the follower. Okay, so there is my follower. And don't really need the original document in this case. I'm not making a change to it. If I continue on with the save as, then the coupler will be a save as, copy and open and save. So what I'd have to watch out for is if this was, so we'll go ahead and keep the original document open in this case, because I do want to make that adjustment. If this was in an assembly and these names were already there, there might be a disconnect in associativity, so we just want to be aware of what we're telling it to do as the save as. All right, so we'll go to 160 millimeters, make sure to rebuild it, save it one more time. My screen's a little bit small there, so let's go ahead and collapse the pull downs, make sure I'm in the coupler, 160 millimeters, and we save it. All right, at that point I can go ahead and close it. Double click on the boss extrude. Again, I'm not going into the sketch. I'm just double clicking on it so that I can change that dimension, rebuild it. I'm in the follower, and we save it. Okay, so that gives me my geometry, and I have enough to go on to the next uh, the rotation pins. Okay, so let's fly this back in here. Go one more. So we have 2 pins, and we're going to do the same thing with um, the single items. Keep in mind you can do these as a configuration. The short pin and the pin. All right, so for short pin and a long pin. If we do this as a revolve, I would tend to want to do the math. Make this a derived driven dimension, and our flange is going to be 2 millimeters, so that I can easily change from 5 to 10 or from 10 to 5, whichever way we go. We have 14 and linear dimension versus the diameter, not a big deal. 10 millimeters on the inside, and then we'll need to kind of make a decision about the tolerance of which way those are going to go, since we're not doing bearings on these guys. So let's go ahead and close that guy out. I'll pick up our new part metric. And to bring this into the assembly, I'd actually like to be in the top plane. All right, so when I drag and drop this, it will already be in place. We go into the line, pull down, grab the center line, make it vertical, infinite length. And because I'm going to close this off, we'll go ahead and set the length. And the top portion will pretty much be the same, and the bottom portion is the one that changes for the sizes. And that did not close off, so make sure to click it. Get back into the select, do the little scroll wheel zoom thing. All right, so my heights are going to be 2 millimeters, 5 millimeters, and it does that little strange jump. And we'll go back and put in the 10 millimeters. Then if I drive the dimension for the overall height, I can do that for verification, and we want to make this dimension driven. Our diameters then, they might change, but probably not. So there's the 10. We're staying in diameter mode. And if I do need to add tolerances to this and drive them individually, I'm going to make those separate dimensions. One of these is going to be the press fit. All right, so this will be the press fit into the body, and then the crank or the follower will be rotating about this. And then when I press into the other side, one of the 5 millimeters, and because if they both rotate and it's not really a bearing surface, yeah, there's going to be some scoring, galling, heat. You know, the functionality is going to be, life expectancy is going to go down quite a bit. All right, so we go ahead and accept the revolve, and the idea with putting it in the top plane is when I bring this in to my into my assembly, that I will have it already in the orientation. I won't have to do that rotation thing. So let's save as copy and open, and we go pin short and save. Don't need the original document open in this case, so we'll go ahead and figure out which one of these is going to change. Make sure to rebuild it, and then we go ahead and save. All right, so that gives us our parts, gives us a direction for the engraving when we go to make that part, make the base, and we'll have to figure out if adjustments are warranted to the crank and follower to improve manufacturability.